Think about is what are we trying to accomplish in this course? And that is have the students what is called in the educational speak called critical thinking. And that is be able to make decisions based upon what they're learning, not just memorize facts. So these folks are doing things that we didn't even remotely think about covering in our courses, maybe bits and pieces. So we're able to take that, put it together, research something that's brand new to them, and in every case, we have some pretty good stuff and it worked. And so we're very happy to see that. Okay, just start it off.
Is it electric? It's okay, they never work.
Okay. Hello, everyone. My name is Kendall Harris, and I'm the students here in ENT-2900. My co-partners are Ms. Yasheeca and Mr. Yasheeca, and we're the first group to go forward. Before we get started, this little thing here for you people that don't know what it is an Arduino Uno. This is just a very small, very flexible, programmable microprocessor. And this is one of the things that we learned in one of our classes here is how to program this guy. And we were given the flexibility of deciding what we want to do during our project. And so we chose to use this guy to make a safe system, which is this guy. So there's one of these mounted in this guy here. Okay, so this is called an Arduino Uno. Combined Radio Shack. Alright, so and what we're planning to do, the first thing we're going to do is first of all tell us what our name is. It is the Kenshaw group, and that is derived from Kendall, Yasheeca, and Yasheeca. And our project name is safe System. And so the first thing right off the bat is we thought that we would, based on advisement, that we would demonstrate what our little safe box can do. So Yasheeca's going to play the video for us to get us started. It's upside down, Yasheeca. Oh, there you go. All right, so that's upside down. Turn that around. Okay, so here's the issue is that we want to have a box that would allow us to have access to, and we'll see what's going on here. This person just punched in the wrong PIN number. Okay, so the system says, hey, that's a bad thing, and the red light turns on. And then he's going to punch in the right number, and you can see that the box opens. And there's a little mechanism here that you'll see, we'll talk about later, which is connected to our servo control motor, which is going to open and close the box. Okay, so we're going to move forward because we want to make sure we can stay on schedule. In our introduction, which we've already said, we're going to talk about hardware. We're going to talk about the software development as well as the website. And then we're going to wrap this up in a conclusion. And what's going to happen here is, are you getting me? Over there. Okay. All right, so what our purpose was to here's first of all, to develop a security system that will allow and deny the access to a user, which we just demonstrated. And our password, our dummy password was 1234, and green lets you in, red denies you, but you saw in the demonstration. And so our approach was threefold. We first of all had to go out and do research, find out what was available, what technologies were there, what was existing, what people had done before us, what libraries were there, et cetera, et cetera. And then after that, we defined our system requirements. You can't do things without knowing what it is that you're really trying to do. So after we established those requirements, then we put into a phase where we designed, assembled, and we did all our testing of parts. Okay, so the first phase was some very fundamental, just get the Arduino to talk to our display with the keypad and just get to run and talk to each other, which is a very fundamental thing. We think it was fundamental. We had lots of problems, which these guys are going to talk to you about. In phase two, we actually worked on
Kendall can't remember the code. It's 1, 2, 3, 4. Kendall, there's no problem.
I just wanted to show you that the latch was inside the servo board. Well, Drew's working on that. We'll talk about it. We're just going to flip the box over so you see how the servo board was installed. And the big part here, we had a lot of fun building our box. We went out to Home Depot. We found some very, very cheap wood. We're going to talk about some of the problems of building with cheap wood as well. We tried to do really low expense everything, low ball everything. And then we're going to talk about the power and portability. When we mean portability, we mean the ability to unplug from the computer. On the side of this guy here on the Arduino, there's a little USB plug and there's power. Okay, so we wanted to show that we can break the tether, the umbilical cord, power this guy with DC power, which is what it's doing now, and unplug. So, and then we're going to talk about some of the optional features, which are just features that only do enhancements, not really there to part of the original requirements to make the box really work. And so we'll come back to that in a few minutes after these guys go through. So now we're going to keep on schedule, and y'all are going to talk about the hardware. What I wanted to show very, very quickly was that telling the box that there is a motor there. We actually built this guy here, put the servo control on it, so we have a latch mechanism. We catch this guy and makes this thing off. Okay, so we're gonna continue on, and here's y'all. He's gonna talk about the hardware.
Hi everyone, my name is Yao Edu, and I'll be talking about the hardware components of the project. The components that we used was the Arduino Uno, as Kendall said, and that was the main processor that we used. And the input was the keypad, and the output that we used was the LCD, the LEDs, speaker, and the servo motor. And the support items that we used was the breadboard and the jumpers. And lastly was the building of the case, which is the storage, and that was the safe box. This is the Arduino Uno R3, and as you can see, it has 13 pins, and it has a ground, a V-in, and a 5 volt and a 3.3 volt output. We use the V-in with a 9 volt battery, and the USB port to power on the Arduino Uno. The second is the keypad, which we use for the input, and this is the schematic of how the keypad looks like, and it consists of rows and columns, and these rows and columns are tied to specific numbers on the keypad. And the keypad has a 0 and a 1 output. The 0 is a low voltage and the 1 is a high voltage. The output, we use the 16:2 LCD. LCD meaning liquid crystal display. And this is the converter that we use to convert the LCD from a 16-pin to a 4-pin, which is ground, VCC, SDA, and SCL. SDA and SCL are connected to the analog in of the Arduino Uno. And the ground and the VCC are power and then ground. This is a picture of the attachment of the serial converter to the LCD. Then the output, we use the red LED and the green LED. The red LED to symbolize wrong password, and the green LED to symbolize the correct password. The servo or the speaker or the buzzer, which is tied to the red LED to indicate when the password is entered wrongly, and the red LED is turned on. It will turn on with the speaker, so the speaker will give a sound as the light is also turning on. This is the integration of the whole project with the keypad, LCD, the chassis, the Arduino Uno, the breadboard, and the wires, everything in there. This is the output, the servo motor that we use for the project. The support we used was the jumper wires and the breadboard. The breadboard was to allow us to be able to easily add in components and easily take out components. And this is the stage that we built the box. with the wood that we bought from Home Depot. And this is the final integration that we did, putting in the first, the phase 3, which is the whole project, into the box. This is how it looked like. The hardware problems that we had was the limited pins on the Arduino Uno. The Arduino Uno had 13 pins, just 13 pins, input and output pins, but the LCD alone just had 16. So to be able to overcome this, that is why we use the serial converter on the LCD, just to use 4 pins, 2 for the Arduino Uno input, and then 2 for power and then ground. This is how it looked like before. And then the next problem that we had was the LCD not displaying the test. And this was because we had the serial converter turned the opposite way. So to overcome this, we had to reverse it 180 degrees because it was negative 180 degrees. So we had to reverse it to 180 degrees. So this is how it looks like with the logs. And we rotating it to 180 degrees. And then the next problem that we had was mounting the hook to the servo arm, because the servo arm that we initially bought, which was like this, couldn't fit in perfectly with the hook. So we had to come up with a makeshift one. We used a hanger coat to come up with a new one, which is like this. So we drilled holes through the servo arm, and then we put in the coat wire to be able to fit inside of it. And this is how it looks like to the precision, how it will work when everything is okay.
This is our alignment problem.
And the next problem was the system draining battery while the entire system was off. And this was because the system was in a parallel connection while it was supposed to be in a series connection. The parallel connection was the red, which is the positive, and the brown, which is the black wire, were all going straight to the switch. That means every time we think the system is off, it is still running. So we corrected this by putting the ground through the switch to the breadboard, and the red to the breadboard straight without it passing through the switch. So I'll hand it over to Yasheeca for her to explain the software aspect to you. Thank you.
Alright, so in making our project, we had to use what are called libraries. So I'll give you an overview of what that is, along with some code examples. And the examples that I will cover are of the keypad, the LCD, the liquid crystal display, and of the servo. So firstly, libraries. What are libraries? In our case, it's not somewhere where you store books. Libraries are files written in C and C++, which are programming languages. And the purpose of libraries are to add extra functionality to a program. So an example in our case would be to enable the Arduino Uno, which is a processor, to get input from a keypad. So we use 4 libraries. The first one, wire.h, is for the serial adapter, which is on the back of the LCD. The second one, liquid crystal, is simply for the LCD or the liquid crystal display. Third one is for the keypad, and the last one is for the servo. So here's an example of our keypad code. So where we have rows equals 4 and columns equal 4, that represents the physical layout of our keypad. So we have 4 columns and then we have 4 rows. In the middle shows us the physical layout of our keypad. So you see 1, 2, 3, A. That's exactly how it looks on our keypad. And at the bottom, we had to assign, the keypad has 8 wires. So we use pins 4 through 11 on the Arduino Uno to connect the keypad to the Arduino. So this works. Up top where it says 0x20, that is just the logical address of the LCD. And if we bring up a picture of the LCD on the left, you see 16 by 2. So that just means the LCD has 16 columns and 2 rows. at the bottom where it says LCD.init, that tells the Arduino Uno to initialize the LCD to turn it on. And at the bottom it says LCD.backlight, that simply turns on the backlight behind the LCD so you can see the screen properly. Here's an example of our servo code. So we have pause, which is short for position, being equal to 600. So pause is a variable, and a variable is simply just a place where you can store information. So we're storing the value 600 in pause. So 600 now is a servo position. And we were trying to use degrees to get our servo to turn, but that wasn't working, so we had to use something called servo position, which is simply just the servo's way of turning in degrees, which humans understand. So in the unlock sequence of our box, we tell the servo to go to 600, which is 90 degrees to open the box. So initially, the servo will start up here, which is 0 degrees, and then swing right, which is 90 degrees, but it understands it as 600. So, which brings us to our software problem. We had hardware problems where the LCD wasn't working, and we also had software problems. So the first reason was because we were using incorrect libraries. Online, we found about 4 libraries, and we had to sift through each of them to see which one worked with our program. And another reason why our LCD was not displaying, it would just turn on, but it was blank, was because we were using the incorrect LCD address. So we found code examples online, and then if you did not change the default address that they had there to what we used, which was 0x20, the LCD would not display because you're not sending it to the correct address. Another major problem we had was with our access denied sequence, and that is when the user enters an incorrect password and triggers the red LED and the servo stays closed. So what was happening with that was that we wanted the program to give an output after the pin was entered. So our password is 1234. So let's say we press 1, then press 4, the red LED will trigger. And that was a major problem because if our program operated like that, anybody could guess the password. So what we had to do was edit the if statement in our program, and I'm just gonna run through quickly what this means. So in layman's term, here when it says if key equals our code, key is what is entered on the keypad, and our code is 1234, which is our password. And current position is where we're going to store what the user entered. And then the program comes on here and says if current position, which is what the user entered, is equal to 4, which is our code, then unlock the door. Unlock the door because the password is right. Otherwise, it's wrong, close the door. So here, you'll see in our other code, the major difference is down here, where we do the same thing, go in and say key is equal to our code, go down here and check it. If it's equal to our code, then open the door. Otherwise, do a check again, and then give us an output. So this allowed us to get an output after we entered the 4 digits instead of after an incorrect number was entered. Another software problem that we encountered was the servo would not turn 90 degrees. So earlier I mentioned servo position. So if we said pause equals 90, the servo would maybe turn like 10 degrees and then go back. So that wasn't operating how we wanted. So we had to use servo positions instead of degrees to get our servo to turn properly. So here again, if we had pause equals 90, the servo would not go to 90 degrees because it doesn't understand that. And another problem that we encountered was getting an accurate schematic. And a schematic is basically a pictorial representation of our physical system. So we found a software called Fritzing, and Fritzing enables us to have a breadboard view of our project. And the problem that we encountered with Fritzing was that it didn't have the exact parts that we were using. So we had to use similar parts to get our project completed. So here, you can see they have a 3x4 keypad. We're using a 4x4 keypad. So this one has 7 wires. So down here, there's a missing pin because this one has 7 wires and ours has 8. They also did not have a serial adapter. They had a generic 4-pin header. It was just a a component that has 4 wires, so we had to use that instead to get the correct output, meaning that using the 4 wires to run to the Arduino Uno. So here we simply have our 9-volt battery connected into the breadboard and the switch, and then we have the speaker, the servo, and the red and green LEDs. In completing our project, we also had to build a website, so we had to decide what platform we were going to use, and we definitely needed something with no coding involved because we already had enough problems programming this. And so we came up on Wix.com, and this, it had a lot of features, and primarily we could have, when you decide the desktop version of the website, it also gives you a mobile version. And then another advantage of Wix.com is that it's free, and then you don't have to code anything, and you simply just have to drag and drop things to get your website out. So we'll just give you a quick preview of what our website looks like, which is here. As I said before, it's mobile compatible, so you can access this website on your phone. So here on the home page, we just have our project overview, all our phases, and today we have updated it to our presentation, which is today. Our blog is updated with all the problems that we faced, and just this is updated on everything that we have done throughout the whole program. And then this brings us near the end of our program, and I'm going to hand it back to Kendall to wrap up everything.
Okay, just wrapping up everything, put together the summary. We talked about additional features. We went back up to the summary. When you take a look at all the different processes that we had going on in parallel, we discovered that, as expected, the majority of the problems that we've talked about today, as well as all the others that are summarized in the final report, are all startup issues. The majority of them are. And so we found that if you could funnel those processes down, you could narrow them. So the further along we got into each of those individual processes that we were integrating our system, the less and less we had problems. In parallel with the box, getting the wood, the cheap wood, and all those things, the alignments, but they all funneled down so that as we got past that initial phase 1 issues, then we were not smooth sailing, but we resolved the majority of our big problems. All right, so then we're going through these additional features. Remember, we talked about those features at the introduction. We said that these guys were just enhancements. Okay, so we never really got a chance to put these guys in, but they were on our list of things to do if we had more time. The motion sensor was just a simple, we wanted to be able to walk up to the box and have an infrared sensor that would detect us and turn the system on. Instead, we went with the little switch on the back, right? The switch works. Sorry. And then the change the password. We thought that we would have time to actually go through and do a random process so that the password would change every day. And then more security features. I think the last thing we're there is have questions and answers if there are any.
How much a box? How much you gonna charge to sell it?
How much
buy one?
How much to buy the box? Oh, I don't know, including our markup or? Yes, ma'am.
What's the purpose of the box?
Well, it's the security, like if you
Well,
want
what
to put
would
your
you
wallet
put
in
in it
there.
that, I know, but then why wouldn't I just carry the box away?
That's the C4 edition. The C4 edition is you carry it away only once. And that's it.
Yes, we just wanted to demonstrate the basic concept. And more security would have been something that you could still in the box.
And so the battery's inside the box.
Yes, ma'am.
So what happens if the battery wears out? How do
Just
you?
plug it in at the side, and then you can open the box via this cable and then change the battery. That's why we had 2 options. So we have AC, which is plugging it into the wall, and then direct current for the battery, which are inside. That makes
So
sense.
if the battery's dead,
Mhm.
it can't get the door open.
So you could just plug
So
it in.
you have to
like
plug it
this.
in and recharge the battery, and then you can open the door?
No.
No, plug it in and then change the batteries, and then after that you could be able to open the door. So
You
have to-
change the battery from the little hole in the back?
No. You open the door.
Well, how are you gonna get the door open?
When you plug it in, it works fine.
I just
It
said
works like
battery
a
or
champ.
no.
It doesn't need batteries when you plug it
It's just
in.
an option if you needed to walk with it. It's portable using the battery. You can still plug it into the wall and then it would work.
Or it would be good for power outage.
Yeah, there you
Right.
go.
And I don't know if you've got it off the top of your head, but we calculated how much time our two 9-volt batteries would stay active. I think the two 9-volt batteries have to drain all the way down to 4 volts before you start worrying about being an open box.
How many,
So it gives you ample time.
amp hours would that be?
Did you figure that out?
Was 0.5, was draining 0.5. Like every single, like the cycle is 0.5. Every cycle is 0.5, that is drawing.
That answer your question?
Half an amp every time you use it, is that what you said?
Like at every single time, I'm drawing 0.5 amps. So
Right.
0.5 of 9 volts is going to like take a while for it to.
Yeah, so we didn't really figure out the
Depends on
answer to your
your
question.
hours.
Kendall, I want people to get an idea of, like, see, boy, they got a microcontroller in there, that must be expensive. Can you give folks an idea how much all that stuff, the
The
different things
Arduino
cost?
cost about $29 or
Right.
$30 or something like that. The servo motor was $5 or $10,
Mhm.
probably something like that. The wood was
Keypad.
was
Like $1
probably
from
three
China.
bucks for the ENT. I think the most expensive thing that we bought was the chassis that put together those things that were in phase 1. That was rather expensive to put that together because it took more than one set actually put them together because it's you can't see it, but it's a double decker. So we've got the breadboard buried up under the Arduino, the Arduino's then buried up under the keypad and the crystal display.
Okay.
So all in all, I would say probably less than $50 probably.
Yeah, sure.
Something
That sounds
like that.
accurate.
Okay.
So if you sell them for $100, you'd be able to make a good quantity of them.
That doesn't count barge cuts.
Yasheeca, just a question about the software. And I realize the standard operation procedure is to like find stuff that other people have written and modify, but it was in C++, which you did not know coming in, correct?
We learned a little bit in our previous classes, but the most that we learned was to blink LEDs, so
Yeah,
we had
okay.
to do a lot of research.
Okay, so, all right, so you had to actually learn some C++ to
Yeah,
modify.
definitely.
It's not just like you're just taking other code out
Exactly.
there and you're actually learning a new language to do this.
Exactly. So what we did was we found a model code, and that was just like the baseline, and then we just had to add features. For example, we did not find a code online that would enable us to reset the servo. We had to write that in. We had to edit the code to fit our display. So we had to customize the basic code to fit what we had. So they didn't have this custom made online.
And I want to point out, if anybody that does software development, you already know this, but sooner or later you need to be able to freeze your design. Because once we got the basic concept going, and they were, hey, we can do this, and hey, we can do this, but you know, it's really very difficult for us to maintain the course, magnitude, and direction. Okay, so that was one of the bigger challenges is how to keep from branching off and staying on course.
That's the problem that the military has with their stuff.
It's always get to those processes, and once we identify what those requirements were, and then freeze that. And that's where we made our decisions as to what was optional, what were enhancements, and what were requirements.
I also assume you had a little problem with crooked wood.
Oh, yeah.